What about money?
Inflation.
Inflation could, yes. How about saving money?
Like 401k.
Yeah, this is true. 401k is a really good one. We call them investments, right? So I know this isn't money, but let's just pretend it is. We have what's called the power of multiplication over the power of addition. So what I mean by that is this. If I decided that I was going to save $100 in a piggy bank, and every month I just said, okay, Thomas, you're my piggy bank, okay? So I just, every month it's $100, okay, $100. That's addition. But the power of multiplication allows us to save and really get rich and over the course of time. So instead of in a piggy bank, I decide that I'm going to go with Mary Grace in her investment company or whatever, and she ends up allowing this to be invested. What happens to this compared to this?
Grows.
It grows, and it grows at what we call an exponential rate. Does that make sense? So the power of, if you get nothing else today, the power of multiplication is much greater than the power of addition. The power of multiplication can be seen in what we call exponential growth, and then obviously division would be exponential decay. Talk to me about a disease. How is that exponential growth, or it could be decay if it's taken lives or something like that. How could that be exponential? Why do we freak out at the CDC when we have a new disease and there's only 3 people that have contracted this disease? Why are we freaking out about that? Yeah. So like over the course of time, it's not a linear line. You follow me? It's exponential growth. Okay? All right, this next thing I'm going to do, this could be the cheesiest thing I've ever done. And I think it might be because other classes have actually made fun of me for this, so I apologize if it is, and just make fun of me and we'll move on. In today's class, I want to start a movement, okay? Now, a movement starts when one person starts something, and then ultimately it just all of a sudden goes to some sort of group of people that they do it, and it just kind of escalates, right? I think of the ice bucket challenge. You remember that? Like one person decided like this would be a great idea, even though it was probably a dumb idea. But then it went to one other person, and then it just spread like wildfire. So I thought, could we do that at GAC? Could we start a movement? So what we're going to do is we're going to start a certain hashtag. In today's class, usually I say no phones out and that sort of thing. Throughout today's class, I will allow you to use your phone at any time. So if you feel inspired and you think, oh, I got this idea, you can go ahead and do that throughout the course of the lesson while you're thinking about it and while we're doing this behind you. But what I'm going to do is I'm going to see over the course of time, over the course of 10 days, can we get something to be an exponential growth model? Now this only works if we have a certain number of people that actually start it and then see where it flies, okay? So here's what we're going to use. I decided to start this thing called hashtag GAC kindness. Again, is this cheesy? It may be. But I just thought, hey, I want to try to see if we can make something exponential, okay? So here's what we're going to kind of plot over there on this side. As you go on Instagram or Twitter, I want you to think of something at GAC that, man, you really want to point someone out. Maybe in a good way, right? In a positive light. Hey, I just think of Hector. Hector's a great dude, right? And when I did this morning, that's what I was thinking of, or who I was thinking of. But I just said grateful for the maintenance team. They make everything look first class around campus, right? And then I just put the hashtag GAC kindness, left it at that. For every retweet we have, I'm going to see how many retweets we can get on new tweets, as well as this one as well. And then over the course of 10 days, see if we can get this to skyrocket a little bit, okay? So, and I'm just making a for instance, let's say Coach Lady has had a huge impact on someone. I just saw Kennedy, and with her being your coach. Hey, throw it out there. Hey, appreciate you, Coach Lady, whatever, yada, yada. And then just include this hashtag here. That way I'm able to go and click on it and follow the amount that's there, okay? And I just want to see, can we make this something that's a movement throughout GAC campus that maybe there's more than just us that are participating in either retweeting or tweeting with that same hashtag, okay? Thoughts on this? Is it cheesy? Might be. Some of you are like, yes. Coach, you're weird. Probably. I'm curious. I'm seeing if we can actually create an exponential model and see if I can show this. If this falls, if this crashes, if this burns, it was Grant's idea. Okay? We're all going to point to Grant, all right? And go from there. But today's class, if you want to, just have your phone out there. If I see you on it the full time, I'll just say, I'll just think you're doing a lot of them, I guess, today. But on Instagram and or Twitter, if you could use that, throw it out there, hashtag GAC kindness, whatever you're thinking of. I think a lot of times I thought about this. Sometimes we, or at least I hear a lot of negative things. I feel like in our society today, everybody's a critic, including myself. And so I thought, hey, well, how can we bring a positive light on campus as seniors, doing it, relating it to math? I thought, man, this is a win-win-win. So we're gonna try it out. And again, if it doesn't work, Grant, and we'll be good to go. Okay. All right. Now, with that being said, let's hop into the lesson. You're gonna want your homework out as we transition through this. I'm gonna hopefully hit and fly through some of this, but some of it we may have to slow down as is needed here. Just as a heads up here, you'll notice that there's a couple things on this that we want to kind of focus in on. In this graph, what would be the domain? Just by show of hand, and we'll kind of go around. Thomas?
Negative infinity to positive infinity.
Good. We say negative infinity to positive infinity. Good. We're just kind of reminding ourselves of these characteristics. What's the range of this? Caitlin? 0 to infinity. Very good. Nicely done. 0 to infinity. You have a game today, don't you? Shout out to soccer. It's soccer tonight. Come and show up. First region game? First region game. Very good. Are we increasing or decreasing? Someone raise their hand, and then if you can, tell me the interval on which it increases or it decreases. Thomas feeling good again? Go ahead.
Is it increasing from negative infinity to positive infinity?
Yes, it is. It's increasing from furthest left, negative infinity, towards the positive infinity side, right? The farthest right. And it is not decreasing, right? Not decreasing at all. In fact, if it was decreasing, this would be what type of model?
Decay.
Yeah, very good. Kayla, did you say that? Good. Yeah, the exponential decay is what we would say there. Okay? Are there any asymptotes here?
No. 0.
Yes, there are. It's y equals 0. You say, Coach, how is that? Well, on the range side, the lowest it can go is 0, so it's approaching this y equals 0 line, but it's not crossing. So make maybe a little note that every exponential model is going to either, whether it's decay or whether it's growth, it's going to have a horizontal at somewhere. Traditionally, it's at 0, but it can change depending upon transformations. Okay? And behavior, we're not going to worry about that. Are there any intercepts? There's a y-intercept, yeah. It's kind of weird. We'll say it's at 1, right? And so we would say there's a y-intercept at 0, 1. Okay? All right, good stuff. All right, so let's go to our next one, which is really what the homework is over. And what I'd like to do is try to start with y equals 3 to the x. So quick question, y equals 3 to the x, what is the asymptote here? It's just 0, right? We start just at 0. So we're going to put that here. Now in creating what the actual model will look like with the growth or whether it's decay, let's create a t-chart here with x and y, where I'm going to put like -1, 0, 1, and 2 in. Okay, let's try it out. So if I put in -1 in for x, what's 3 to the -1st power? What would that produce? Not quite, Josh. It's a good thought. 1/3. Okay, I did that just one time. I wanted you to remember that. A negative exponent does not make it negative, it just flips it. Okay? So again, 3 to the negative first is just 1/3. Okay? Just 1/3. Josh, you know what 3 to the 0 is?
0.
Not quite.
1.
1. That's it. Good. Anything to the 0 power is always 1. And then 3 to the first is? 3. And then 3 to the second is? 9. Good, Zari. And again, our horizontal asymptote would be at 0, right? Y equals 0. Cool. Questions on that? Good stuff. Let's go here. Let's start here and go -1 and 1/3. We'll go 0 and 1, 1 and 3, and 2 goes all the way up to 9. So this thing's going to go down, 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 and it's going to approach that y equals 0 horizontal asymptote. Okay? Good stuff. Exponential growth or exponential decay here? Growth. Very good. Is exponential growth good or bad?
Good. Depending on what it is.
Yeah, exactly. Talk about a disease, that's bad news. Talking about money, that's good stuff. Tomorrow we'll actually look at exponential growth. If you gave up Starbucks for the rest of your for the next 20 years and you just invested that money into an account, how much money would you save? We're going to look at that tomorrow. It's quite a bit. It's going to be kind of impactful tomorrow. It'll be pretty impactful. Okay, so let's go here. Let's go on this. These top 4 is what I'm focused on. If I were to shift this up 2, shift it up 2, what would I do with y equals 3 to the x? If I wanted to push it up 2. Good, we put +2 where, Mary Grace? It'd just be at the very end. Good. So up or down, we're going to put it at the very end. +2 at the very end. Okay? So vertical shift is just tagged on the very end of the equation. So what would be the horizontal asymptote of this right here? It was at 0, right? But if I shifted everything up 2, what also would go up to? The asymptote. Good, Emma. Good. It would be at y equals 2. So this horizontal would be at y equals 2 for 3 to the x plus 2 on the outside. Okay? All right. Am I going too quick or is this okay? We're good? Okay? The next one is left and right. So if I was to shift this left 2, what would I do with the equation to shift this left 2? So we have x here. What would I do with that 2? Good. Yeah. Good. So did I say left 2 or did I say right 2? Left 2, so it'd be +2. You're right. So it'd be x plus 2, and again, that would be in the exponent. Good, Zari. And we would put that down on the top. Okay? What would be the horizontal asymptote of 3 to the x plus 2 here? I've got 3 right here, if you could tell me.
What was your question?
What would be the new horizontal asymptote of 3 to the x plus 2 with the +2 in the top of the exponent? What would that be? Thomas?
Would it be 1,
Not quite.
2?
Why?
There's no up or down shift.
Great job, Evan. So look right here. If I went left 2, right? If I took this horizontal asymptote and went left 2, did I change it?
No.
Does that make sense? If I just shifted this left 2, the horizontal asymptote would still be y equals 0. So what changes horizontal asymptotes? What type of transformation?
Up and down.
Up and down or vertical transformation. Does that make sense? Cool. Are we good around? All right, last 2 things, and then I'm going to allow you to do one. Over here on the reflection over the y-axis. Reflection over the y-axis changes something from a growth to a decay. So what would happen is if I were to reflect this, this thing would now look like it would literally just be a reflection over the y-axis. So it turns into this green part here. So what could I do to y equals 3 to the x to make the new graph look like this in green? Josh?
Negative x.
I like it. Good job. So right here, this would be y equals 3 to the negative x. Great work. So if you think about it, if the x is negative, it reflects over the y-axis. It's like opposites there. Thomas?
When the x is negative, does the like x plus 2, does that just mean plus or go to the right instead of the left?
Correct. Because you said it equal to 0, right? Good work. Yeah. Good work. We're going to look at that one here in a second. I know what you're talking about. All right. Good stuff. We good so far? Okay. Let's take a look at the last one here. How do I change something to where it's reflected over the x-axis, to where it goes from the yellow to the purple? What would I do with this equation that's different than here? Caitlin? Nice. So the negative goes in front of the actual base rather than the exponent up at the top. So when the negative's in front, what is up now gets reflected downward. So we reflect it over the x-axis when the negative's in front. Okay, thoughts there? Good. Okay, try this out. I want you to just, with someone around you or with a group of you, I don't know if there's an actual place to graph this on there.
There's not, it's just ask this shit.
If there's not, maybe you just do it right on your desk, or maybe you make your own plot. That's fine too. But you could do it on your desk as well. I want you to describe this transformation in relationship to 10 to the x. And then I want you to graph the one on the right-hand side. Okay? I'll give you a couple minutes to kind of test that out with someone around you.
Can I go to the bathroom?
And we'll go. Yeah, Kennedy, you may. You want? Try graphing 10 to the x first. There are markers over there? Here's this right. I've also got some graph paper over here if you want it on some of the note sheets. So if you want one over here, there are some over on that side too. I'm sure this one's on the homework as well. So you can do that. I would start with this one. That way you can check it with me, and then you can come back to that. Do this though. Let me answer your question first because you're gonna ask me something.
So like,
So what I would do is go ahead and graph 4 to the x power first, and just graph that normally, and then the transformations that you would have would be what would happen with this plus 3, up 3, and then
So if it's positive, is it just right?
good. Then you can take each of the points and go up 3 and right 3.
If it's positive, it's just right. You look at 10 to the x power. Cool. What is the horizontal asymptote? Just 10 to the x. You good? It's 0, right? It always starts at 0. So anytime I have this, just a base, no transformations, the horizontal would be y equals 0. Okay? In this t-chart here, for just 10 to the x, right? What would be my y if I plugged in -1, 0, 1, and 2? So if I plug in -1, what's 10 to the negative first? Well, with the negative exponent, we just flip it, right? So that would be 1/10. Does that make sense? Kind of, sort of? Okay. What about 10 to the 0 power? Good. 10 to the first would be? And 10 to the second? 100. Good. And then I'm going to go ahead and plot those real quick. See what you get. Okay.
There's a negative x, negative 1. That'd be positive.
Yeah, so that's a good point. What types of transformations are occurring right here? Josh? Good. Reflection over the what? Y-axis, good, because you think opposite, right? With the negative with the x, it reflects over the y. And what about the +3? What is this going to do? Usually it means left 3. Here's what's weird. If I set negative x plus 3 equal to 0, how do I get x by itself?
Subtract 3.
Good. Good, so this would be really moves to the right 3. It's a little different. Normally, you're right, you could just change the sign and be good, but that negative x throws
So if
us
it's
off.
positive x plus 3, then it's negative 3.
Exactly. Normally, that's how it is, right? It's good. Is everyone okay so far on this? Elijah, did you graph that first one? No, not yet. So we got -1 and 110, 0, 1, 1 and 10, and 2 and 100. That's way up there. So we have something that looks like this. Is everyone good on the yellow one for the first equation? I just wanted to make sure we get one rep in off this homework. Now, I don't know if everyone heard me, but I want to make sure that everyone's kind of on the same playing field. Did everyone say that we reflected over the y-axis and went right 3? Is everyone good on that? Okay, so here's what I would do first. Reflect this first over the y-axis. So right here, if I were to reflect this, this is going to go here, here, and here. So that would be the first exponential equation, okay, when I reflected it. Now, if I push this right 3, where would this then go? Well, we'll then take the blue one and just push each of these points right 3. 1, 2, 3, 1, 2, 3, and 1, 2, 3. So the new one would look something like this right here, okay? You see how I have 3, but really it's only 1? I just wanted you to see how it transforms, okay? Cool?
So it's just x plus 3.
Are we doing 1 to 1?
Yes, we are. We are. Are we good on that? The 1-to-1's pretty easy, though. How are we doing on time? We got... Oh, we good. We're good. We got 9 minutes left. Let's go to the last thing. Go to the last thing on your homework, okay? This is called 1-to-1. 1-to-1 functions. And basically 1-to-1 says this. We can solve for exponents, or x, by making the basis to where they're the same. We say that it's 1-to-1 when they're the exact same. So like look at this one here. You'll notice the bases of 4 are the same. So we're able to cancel these out, making it 2x minus 3 is equal to x plus 7. Cool? Then we just get x's to one side by subtracting this x, and then adding 3 to the other side, and we get x is equal to 10. Okay? Now that one was pretty easy, right? Because you've got the same bases. What happens when they're not the same? So like if I were to go 4 to the x equals 2 to the 8, is there any way that I could change 2 to be anything less than 2? That actually, I think we could do that if we worked it that way. I think there might be an easier way by doing the opposite of what you said, although that's a good thought. So if I did change 4 to a base of 2. So 2 to what power is 4? 2, right? So 4 changes 2 to the second. Does that make sense? So like change it to where it's smaller than. And on the right side, keep 2 to the 8. Now what do I do with a power to a power? We multiply it. Good, so we get 2 to the 2x equals 2 to the 8. And again, what we can do now is cancel, leaving us 2x is equal to 8, and therefore x is equal to 4. Good. And that would be our answer. So it's all changing it to where it has the same base. Now take a ride with me, take a journey with me on this next one. This becomes a little tougher. 16 to the 2x equals 1/8 to the x plus 3. Thoughts on how we could change this one? Again, we only can change our bases, right? Trying to get them to where they're the same.
Divide 16 by 1/8.
Say that again, Josh.
Divide 16 by 1/8.
I can't divide because this is an exponent right here. So I can't just divide them. So I have to change it to where we have a different base. Right? Caleb?
Can you change the 1/8 to 8 to the negative x minus
I like it. So I'm going to do this just so that we back up for those that are maybe a step behind. Change it 8 to the negative first and make this x plus 3. I like that. But the problem is can I get 16 to where it's 8 to some power? No, right? So we can't. We got to go even further than that. So that's a good thought, Caleb. Can I change this to 2 to some power? 2 to what power is 8?
3.
2 to the third, right? 2 to the third. And because it's a negative, we just say this is 2 to the negative third, and then x plus 3 on the outside. I'll move MJ over here. Here we are. What about the left side? Can I change 16 to have a base of 2? 2 to what power 16? Sorry?
4.
4. Good, yeah. So we'd say 2 to the 4th to the 2x. Do they have the same bases?
Yeah.
Yes, they do. And I would first multiply these exponents together to get 2 to the 8x is equal to, multiply by negative 3, 2 to the negative 3x minus 9. Cancel out the 2's, and then I'll just set 8x equal to negative 3x minus 9. And that's how I would set up the one-to-one functions that are there. Okay? Again, remember, when you have a fraction, Kayla did it and helped us out with this. Change it to a negative exponent to make sure you get it out of the denominator and into the top. Okay? Good. Good, good. You want to try some of them on your on the back side of your homework. You can go